Now students, again we learn some numericals in this video. Number 2 numericals. Find out or find the ionization energy of sodium with the help of the following data. The data is given students. So lattice energy of sodium iodide is minus 692.0 kilojoule per mole. Heat of formation of sodium iodide is equal to minus 287.9 kilojoule per mole. Heat of sublimation of sodium atom is equal to 108.4 kilojoule per mole. We have to find out the ionization energy of sodium atom. So that is question mark. Heat of dissociation energy of iodine is equal to 106.7 kilojoule per mole. And electron affinity of iodide ion is equal to minus 306.4 kilojoule per mole. Students, the kilojoule per mole is actual small k capital J per mole. Okay. Now the answer is given data. So we have to supply it with this value. U is equal to minus 692.0. Delta HF is also provided. So it is minus 287.9. We have to sub with the value of delta HS which is 108.4. HI we have to find out. SD is given 106.7 and electron affinity which is minus 306.4 kilojoule per mole. So student, we have to remember our equation. U is equal to delta HF minus delta HS plus delta HI plus half delta HD plus delta HE. Now students, for this solving this numerical we require this equation. So very simply from again Hess's law, delta HF is equal to delta HS plus delta HI plus half delta HD plus delta HE plus U. We put the value from our given data, and so delta HF is given minus 287.9, delta HS 108.4 plus delta HI, this is our goal. We have to find out ionization energy plus 106.7 plus in bracket which is value minus 306.4 plus minus in bracket 692.0. We solve this equation by simple modification. Delta HI is equal to minus 287.9 minus the whole value 108.4 plus 106.7 minus 306.4 minus 692.0. We first solve this equation. Delta HI is equal to minus 287.9 minus, first we have to combine the plus value which is 215.1 and then combine the minus value which is minus 998.4. So minus it is plus, that's why it is just get summation. Now we solve this equation in simple form. Delta HI is equal to minus 287.9 minus in bracket minus 782.3 or 782.3. So minus become plus. We get delta HI is equal to minus 287.9 plus 782.3. Very simple. We get this equation delta HI. When you solve this equation, we get delta HI is equal to 494.4. So the ionization energy of sodium atom in sodium iodide is equal to 494.4 kilojoule per mole. Always remember that ionization energy is in positive sign, so is the answer also in positive sign. Student, we have to complete the numerical from the Kapuscinski equation, which is also important from your exam point of view. That is, calculate the lattice energy of sodium nitrate from the following data using Kapuscinski equation. So the value is given, radius of sodium ion, that is Na plus, is equal to 97 pico pm, which is picometer, and radius of nitrate ion, that is NO3 minus, is equal to 189 picometer. So you have to just see that sodium ion having small radius. So student, answer before that, the given value in sodium nitrate, the number of ions is equal to V, that is 2. So Na plus is 1 and NO3 minus is 1, so it is 1 plus 1, 2. So V value is 2. The value of constant is given also in your exam. So constant C is equal to 1.079 into 10 to the power 5. The value of R plus, that is Na plus, is given 97 picometer. R minus for NO3 minus is equal to 189 picometer. We have to find out the lattice energy. The equation is like this. Substitute the value of above in Kapuscinski equation. So UL is equal to CV Z plus Z minus divided by R plus R minus. So students, we put the value of that constant is 1.079 into 10 to the power 5 into 2, that is V value is 2, into plus 1 into minus 1 divided by 97 plus 189. We solve this equation like this. The value is minus, so 2 into 1 into minus 1, so it is minus. So 2 into 1.079, we get 2.158 into 10 to the power 5 divided by 286. In simple form, UL is equal to minus, we get is equal to minus 0.00755454 into 10 to the power 5. We solve this equation, solve this digit in simple form. So lattice energy is equal to minus 754.54 kilojoule per mole. So we have to theoretically find out the lattice energy of sodium nitrate molecule, ionic compound. So students, in this way we have to complete your first chapter, and in shortly we have to start with the next chapter in next week.